Okay. Melissa. Okay, Melissa, you may get started.
I'll start, Philip.
Okay.
Yeah, and then I give over to Melissa. Good morning, good afternoon, good evening, everyone, all stakeholders and the participants today. Thank you so much for joining us for the webinar today. My name is Mernouche Azodi. I'm a Program Management Officer at the Basel Rotterdam Stockholm Convention Secretariat. I work in the Science and Technical Systems team. And for today, I'm the moderator of this webinar. About me, I did a master's degree in nanotechnology and a doctoral degree studying the environmental implications of nanomaterials, engineered nanomaterials. And today it is my privilege to moderate this important dialogue that the BRS Secretariat, along with UNITAR, have co-organized. For today, we have 5 speakers. Please do stay with us until the very end. We will have Q&A interactive session. There's a chat box. You can find it on the right bottom corner. You can write your comments and questions to the speakers during the presentations. After all the presentations are over, we come back to that. And if there's sufficient time, we try to ask as many questions as possible from our speakers. And if we can't ask all of them, our colleagues today are going to collect those questions, and we hope to get back to you on those later. The objective of today's webinar is to enhance our understanding of nanomaterials and their implications for waste management specifically. We would like to provide you with an overview of existing body of knowledge, including scientific developments, regulatory frameworks, and best practices in the management of waste containing nanomaterials. We would like to facilitate a dialogue among parties to the Basel Convention, academia, NGO, private sector, and all stakeholders who are interested in the topic to share insights, experiences, and innovative approaches to for the sound management of waste containing nanomaterials. And so with that, and without further ado, I would like to get started inviting Ms. Melissa Lim. She's a Program Management Officer at the BRS Secretariat, and she'll present to you a summary of the activities of the Secretariat in the past few years on the topic, and also a summary of a report that was prepared by the Secretariat on issues related to waste containing nanomaterials and options for further work under the Basel Convention. With that, I would like to welcome Melissa. You have the floor.
Thank you, Mernouche, for this introduction. So, and I have the privilege of starting off. Okay, so today I'd like to give you some of the considerations for thinking about how to address waste containing nanomaterials, but specifically in the context of the Basel Convention. There is a lot to think about and many aspects to consider in trying to address the potential impacts of the use of nanomaterials. And a few years ago, in 2017, and parties of the Basel Convention came together and decided to initiate some work to look at what needs to be done for the environmentally sound management of such waste, and in the context of the Basel Convention. And therefore, I'd like to start by a reminder of what the Basel Convention is about. So I think we have with us many parties who are more than familiar with the convention, but for those who are not, it's an international treaty that rests on 3 pillars, which is to minimize waste generation, promote environmentally sound management, and control transboundary movements of waste. And by waste, I mean those wastes that are within the scope of the convention. And these, broadly speaking, are hazardous waste and other waste. And I'll go into some more detail about scope later on. Yeah. So as I said, in 2017, the Conference of the Parties, which is the governing body of the convention, requested the Secretariat to prepare a report to help it with decision-making on what to do with waste containing nanomaterials. So, and to look at some recommendations for what possible work could be done in that regard. And this report was then presented to the Conference of the Parties 2 years later. And at that time, the COP took note of the report, and it encouraged parties basically to do further work to collect further information on such wastes, on strategies for their management, and then to share that information with the Secretariat. Manush will tell you more about the follow-up actions at the end of the webinar. So, as I said, this report was developed by the Secretariat, and it's available on the website of the convention. And here are just in an outline of the main topics that are covered. And I will briefly take you through some of the key elements to explain the thinking and the context for the work. The scoping of the report was very important because the question at heart was, how do you achieve environmentally sound management of waste containing nanomaterial? Then you have to ask yourself, what does environmentally sound management mean? The convention itself has a broad definition of this concept. And a few years ago, experts under the convention came together and elaborated on their common understanding of environmentally sound management and produced this framework that is also available on our website for further consultation. And they came up with a few prerequisites for achieving ESM. And two of them are, and the most fundamental, I would say, are having a clear picture as to what wastes are arising, the quantities that needs to be managed, and then understand how these needs to be managed to ensure ESM. So essentially, in order to even think about how to manage waste, you need to know what they are, right? The framework contains a number of other key elements, such as having sufficient capacity and also ensuring compliance, monitoring, and of course, key to the Basel Convention, ensuring that transboundary movement of these wastes are in compliance with the convention. But fundamentally, first, you have to understand what the wastes are and what is happening to them. And so the report goes into exploring these issues to look at whether these two preconditions are achieved. As a reminder, waste under the Basel Convention are defined by the article of the convention itself, and further through its annexes. So there's Annex 1 that has a list of waste streams and waste constituents, and then Annex 3 lists the hazardous characteristics that are exhibited by a hazardous waste. And then, of course, the convention also allows for national definition of what hazardous waste are. And you also have Annex 2 waste, which are called other waste. And these waste, the hazardous waste and other waste, then are subject to the transboundary movement provisions of the convention. So one of the questions, of course, is whether the waste containing nanomaterials fall within the scope of the convention. because there are already a whole list of constituents in Annex 1, some of which could be considered to be nanomaterials. To be able to answer that question, then we need some more background and more understanding of what nanomaterials are. And this is what the report provides in some detail to look at the state of understanding regarding the definitions and properties of nanomaterials. And at that time, and I think that's still the case today, there was no international agreement on a definition of nanomaterials. But broadly speaking, it's the size of the material that determines that it's a nanomaterial. And the report also goes on to explain that it's a very complex set of chemicals and not just one element, and that these chemicals have complex properties because they have very diverse structures, and their behavior in the environment actually can change depending on how these structures are themselves modified. So complex set of chemicals and complex behavior, which of course makes the determination of their impacts on human health and the environment very complicated. And here, one question that was under consideration is whether there are hazards that are specific to engineered nanomaterials, because the convention has in its annex a number of defined characteristics. But is there anything special about engineered nanomaterials that then need to be, well, further thought of in terms of how they need to be addressed? And one element that the paper pointed at was that drawing firm conclusions was really difficult because of the complexity in analysis, and the diversity of the chemicals made it difficult to compare across studies because there was no methodological uniformity throughout, as much as in analysis of the chemicals themselves in the waste, but also as to their effect. And of course, as I mentioned earlier, the complexity of the chemicals influences their behavior in the environment, which adds yet another layer of complexity in terms of understanding behavior and fate in the environment and potential impact. So, yes, not last but not least, in the background, which sets let's say, the foundations for further analysis, the paper points to the fact that engineered nanomaterials are used very widely in diverse industries. So, and this is very important to take into account in trying to understand what wastes are arising. Turning to our original question, which was, can we have a clear picture to the wastes which are arising? We have to consider that there are, well, three main broad categories of wastes that we can think of, namely manufacturing waste, and one, I would say, important waste stream though is those arising from end-of-life products that contain nanomaterials. And finally, you would also have wastes that are unintentionally contaminated with engineered nanomaterials. But again, here, the report highlights the paucity of data in terms of understanding which products contain nanomaterials or even the manufacturing waste streams, in part because there is no mandatory disclosure in many countries on the use and on the production of engineered nanomaterials. So there are estimates in the literature on understanding what are the impacted waste streams, but many of these estimates are based on modeling. Because again, the available information on where the nanomaterials could be is very limited. Similarly, understanding disposal pathways is also based on modeling, because of the limitation in knowing what the wastes are. And so here, this modeling approach, generally speaking, is looking at what are the production amounts, and then trying to understand where these quantities are used, in which kind of products, and how then the wastes arising from these products are managed in each country. And I say in each country because then in the models, it's clear that, well, the fate would really depend on how these wastes are managed locally or regionally. And there are several studies then that have come up with estimates on the fate globally of waste containing nanomaterials. One of such is that in the EU, for example, one estimate would be that 50% of all engineered nanomaterials end up being recycled, and then different values for incineration and landfilling. But this is just one of the studies, and depending on the model and the input data, of course, you have different estimates. Now, that was the background set forth in the paper to try to address this fundamental question of whether we know what wastes are, and what waste containing nanomaterials are, and what's happening to them. And then the next question explored is, well, if we look at the main treatment processes for waste containing nanomaterials, what is the fate of nanomaterials then within these processes? And here the focus is on recycling, incineration, landfilling, and biological treatment. And the question is, of course, do these processes as they exist today end up destroying nanomaterials, or are there releases to the environment which therefore have to be managed to prevent exposure, either occupationally or, of course, impacts on the environment? In summary, then, the paper exposes that, well, there's a lot of uncertainty around engineered nanomaterials and waste containing them, and the impacts on human health and the environment, because of this issue of that I have explained earlier. And then because of these uncertainties that are numerous and likely to remain, given the complexity of nanomaterials, some have proposed that a precautionary principle needs to be applied in the regulation of nanomaterials and waste containing them. And then, of course, more transparency in the content of products is essential in order to answer that fundamental question as to what wastes are arising and what happens to them. The paper also summarizes some of the findings of the fate of nanomaterials in current disposal facilities or processes. And in a nutshell, the conclusion was that, well, there might be some releases from incineration, but advanced facilities should be should have the capacity to contain ENMs. Whereas in landfilling, concerns about leachate, especially, of course, in uncontrolled landfills, is a big concern. And the use of sewage sludge that contain nanomaterials is, of course, something to pay attention to, because, as I mentioned, we have still poor understanding of the behavior of these substances in the environment. Finally, the paper goes on about goes into further work that could be done, and in 4 broad categories. One was to look at whether to explore further whether waste containing nanomaterial falls within the scope of the convention. And the other is to encourage more research and activities to understand and to fill the data gaps that exist, and also to understand further strategies and approaches that need to be put in place in order to manage waste containing nanomaterials. And as I've alluded to earlier at the beginning of my presentation, the Conference of the Parties have picked up on some of these recommendations, and the activity today, this webinar, is part of the attempt to promote collaboration and dialogue on these important issues. Thank you very much.
Thank you so much, Melissa, for this great introduction into nanomaterials and the activities of the Secretariat. I think, and I'm sure everybody agrees, that you brought up a lot of different topics related to the issue, including the release of nanomaterials, the issue with their disposal, and their possible leaching into the environmental receptors. So with that, I'd like to our participants to think about all these topics that Melissa presented, and the 4 speakers will talk shortly on. We have a poll question for you, one single question at the end of this session, to explore the topics that you'd like to hear more on from the Secretariat in the future. So think about that. What would you like to be the focus? And we come back to that at the very end of the webinar. With that, I'd like to now invite Mr. Oliver Wooten, a program officer at UNITAR. UNITAR has been working on nanotechnology and implications of nanomaterials for the environment, including capacity building and awareness raising activities for the past several years. So we're very happy to have Oliver today to give us an overview of UNITAR's activities and perspective on the sound management of waste containing nanomaterials. Oliver, you have the floor. Thank you so much.
Thank you very much, Manoush. And can you see my PowerPoint? Is that sharing okay?
Yes.
Perfect. All right. Thank you very much. And thanks to everyone for joining today, and for my co-presenters. As Manoush said, my name is Oliver Wooten. I work in UNITAR's Chemicals and Waste Management Programme. I look after a range of our portfolios, including the GHS, our mercury-related work, convention ratifications, and nanomaterials as well. So I've been working on this since 2015 with one of our colleagues, George Karliganis, who might jump in with some additional comments at the end of my presentation. So just very quickly, certainly for those that don't know, UNITAR is a training arm of the UN focusing on capacity building research, training and support for activities and research. We have several divisions and work areas. These range from peace building, diplomacy, trade, and more. I work in the division for Planet, the Chemicals and Waste Management Programme. And we have experience in supporting national activities, mercury and POPs management, chemicals and waste action and implementation plans, nanotechnology, ratification of conventions, pollutant release and transfer registers, the GHS, and others. And within this, some of the activities we often undertake are to develop guidelines. So we've done this on national waste management, developing mercury inventories, studying socioeconomic impacts of mercury, and I will introduce shortly our nanomaterial guidance as well. So our activities, we'll run through these sequentially in our presentation, but I'll present our e-learning course, our work under SciChem, how this is transitioning to the new global framework on chemicals, and then our work specifically related to the waste-containing nanomaterials under the Basel Convention. To start off, we have our e-learning course. So some of you may have seen this. You may have seen some of the marketing. We started this in about 2013, 2014 with a course developed with expert tutors. We ran that every year for 2 or 3 years, engaging some stakeholders around the world who were looking to learn more about nanomaterials. In early 2020, 2021, we did a big revamp of the course. So we revised this to update with new knowledge, the new situation regarding SciChem and the presumed new framework that was coming at that time. So we worked with the authors. So we had Vladimir Murashov from the US government. We had George Kalaganis as well. We had based the work on Rob Visser, ex-OECD employee who worked on it, and I also supported the team on doing reviewing. Also, the University of Fribourg helped us with some expert content as well. And since 2022, we've had 109 certificates delivered to participants. Just briefly, the course is made of 4 modules. So there's an introductory one with definition, properties, use and commerce of nanomaterials. We go into quantification methods and OECD test guidelines. Module 2, we're talking about the hazard assessment, workplace safety, consumer safety, environmental risk assessment. Module 3 goes into risk management, and this includes societal dimensions and considers some of the global approaches. And then module 4, we have sound management approaches, including roadmaps and some different country examples and regions. On to our work under SciChem specifically as an emerging policy issue. So at ICCM 3 in 2012 in Nairobi, nano was recognized as an EPI. There were 13 activities linked to nanotechnologies, and these were incorporated into the SciChem Global Plan of Action. And with this, Nano Resolution 3.2e was adopted. And ever since then, the Nano EPI has been led jointly by UNITAR and OECD, who you'll hear from shortly. Just a brief snapshot of some of our regional meetings that have been in support of that SciChem work under the EPI. And we've gone around several of the regions, starting with a round of regional meetings in 2010, 2011. We went again in 2015, 2016, and also in 2018. And you'll notice some of those were back to back to the Basel OEWG 11. Just a few highlights from those regional meetings. So in 2015, one of them was hosted in Colombia, in Bogota, for the Latin America and Caribbean region. One outcome document was produced, both in English and Spanish, on safety issues in the region. And as a result of the meeting, there was development or agreement to develop a nano network for the region. We shared information on activities at global and regional levels. And within this paper that I provided the screenshots of, there was development of short and medium-term action plans. And I saw in the participants today for the webinar some people I know from that region who joined our meeting. So very pleased to see some old names that I recognize. into 2018, one of the focuses of those regional meetings was also to help disseminate the WHO guidelines, which were published right around that time at the end of 2017 or early 2018. So we used the workshops to share those guidelines. Several WHO or sort of Ministry of Health colleagues, health sector colleagues joined those meetings and to hear more about the guidelines. And so we had WHO presenting. We also had some of the relevant experts that worked directly on the guidelines, and those are available on that link on the screen. In the past, we've also undertaken national projects. So these are preparatory activities, including identification of a lead agency for nano issues and key ministries and other stakeholders involved in and interested in nanotechnology issues. There was also work done to update a national profile for chemicals management to include a new chapter on nanomaterials and development of a national policy or action plan on the management of nano. We also undertook some identification of key health and environmental protection related priorities and including nanomaterial safety as part of the country's national programme for the sound management of chemicals. So those 6 country projects were run between about 2012 and 2015. They were supported by the government of Switzerland. So in Armenia, one of the outcomes included the formulation of a nano safety policy and a chapter in the national profile. In Jordan, there was a general awareness raising and development of workplace guidelines. In Nigeria, there was a chapter in the national profile and information exchange between stakeholders. Then we had one in Uruguay, another assessment at the national level and a proposal for a nano safety plan. In Vietnam, there was a review of activities and research going on in the country, assessment of priorities, and a proposal for activities with a nano vision for the country. In Thailand, there was also a national profile chapter, nano safety policy and safety training. And this is another area where you'll hear more today from the presenters. I mentioned guidance documents that we develop, and nanomaterials is very similar. In 2011, we developed guidance for developing a national nanotechnology policy and program. Again, this is working with experts, colleagues among the IOMC to develop this document for use in countries. So it has 2 parts. There's a general background and introduction part, and then it goes on into developing national nano programs with some of the key elements that you see here on the screen. Moving on to the global framework on chemicals. So previously we'd been working on nanomaterials principally under SAICM as an emerging policy issue, but obviously that came to an end. Formally, negotiations carried on, but was intended to end in 2020. Back in 2023, there was a resolution, V5, on emerging policy issues and the new issues of concern. So at ICCM 5, they decided that all existing EPIs should transition on an interim basis to issues of concern as part of the GFC. So this provided us with a mandate to continue our work and supporting stakeholders around the world, considering nanomaterials. UNITAR and OECD were also requested to report to the first international conference under the GFC on progress, opportunities to further address the issue, and a recommendation for the future, particularly to relate the work we're doing and to fit it under the new process for issues of concern. And that's anticipated to take place in 2016. During this time, also as Melissa mentions, waste containing nanomaterials has become a bigger discussion point under the Basel Convention. So I won't go too far into this because Fabienne will be presenting, but in UNITAR, we had the idea that we would try to contribute further to the body of knowledge on this, understanding that there was a need for awareness on nano or waste containing nanomaterials. So we've been following proceedings under the Basel Convention. We've been contributing to knowledge gathering and creation, and we have submitted information and worked with other stakeholders to do that. As I mentioned, we held some regional workshops back to back with a previous OEWG, and we undertook the development of an academic article engaging an academic institute to do that work. And some of the conclusions that we see currently, that the nano regulation has reached the mainstream of chemicals regulation in developed countries. Over the last 15 years, during regional meetings, many developing countries and other stakeholders have shown a desire to implement nano safety programs. And several developing countries have developed elements of nano safety policies and strategies. And the new Global Framework on Chemicals and the Basel Convention are effective global platforms to make progress in nano safety. Thank you very much.
Thank you so much, Oliver, for that great overview. You can, I think that was very comprehensive to know what Unitor has been doing and the plans to do in the future. Do reach out to Unitor if you have questions or your suggestions also for future activities. You know how to reach him. I'm sure you're all familiar with. We're interested to know if you've been participating. Oliver says some of the participants from the regional workshops are now here with us today. That's great to have them. But do let us know in the chat if you've been participating in those regional nano safety workshops, and if you actually have started and finished the e-learning course on nano that is developed by Unitor. That's also a very good introductory course if you want to become more familiar with the topic. And so at the end, by the way, the direct link to the report that Melissa presented, the issues related to waste containing nanomaterials and options for further work under the convention, is now in the chat. So please click and save the report for future read. With that, thanks again, Oliver. And now I would like to invite Ms. Mar Gonzalez. She's a policy analyst responsible for the nano safety program at OECD. OECD is a leading international organization in the field of international collaboration and cooperation, standard setting, and policy development. And we're very pleased to have Ms. Gonzalez today to give us an overview of OECD's outlook into the issue of waste containing nanomaterials. Ms. Gonzalez, over to you. Thank you.
Thank you so much, Manoj. Can you share my slide? I can see those of Melissa. I don't know if that's, yeah, perfect. Thank you so much. So thank you so much for the invitation today. So I was invited here to give you a quick overview of the work that we're doing related to nanomaterials, and perhaps I take the opportunity also to introduce advanced materials, which is one of the new areas or the future areas that we are looking into. So I have been working at OECD for the last 20 years, and the last 18 we have been implementing the program on nanomaterials. So the OECD has a program on industrial chemicals. So we deal with risk assessment, risk management, biocide, pesticides. We have, for the last 18 years, devoted a whole program for addressing nanomaterials and see how we can align them to the rest of current practices. Just to give you a additional background, so the OECD might be one of the organizations that you don't hear much about, but we are part of the Inter-Organization Program for the Sound Management of Chemicals. And as Oliver before me mentioned, we collaborate amongst all these organizations to try to fit in and to provide input for addressing areas that are of common interest. So the focus of today, as I said, is going to be only on the program on nanomaterials. So if you can go to the next slide, please. When we started the work on nanomaterials 18 years ago, we were really trying to answer some of the questions about, what are these materials, how they behave, are they safe, can we use existing methodologies to address their safety? So as it was also mentioned in the previous questions regarding waste management. And I think the main focus that we have here is really to develop harmonized tools for the safety assessment of nanomaterials, more recently looking also at advanced materials, to identify potential concerns related to emerging materials or more complex materials, develop the strategies to address them, enhance regulatory preparedness, enable regulatory compliance. So you have, you can see that I talk a lot about regulation because this is one of the key components of our work. And with this in mind, we have work in 4 areas. So one is on the testing and assessment. So this will be typically looking at whether existing methodologies are applicable to nanomaterials and to which ones. So some of the work that we are currently doing is, for example, updating guidance on sample preparation and dosimetry, developing guidance on grouping for nanomaterials. We are also identifying specific test guidelines needs or guidance documents that needs to be developed. But what we do is that at the same time, we try to anticipate what could be the needs or what are the documents that we need to develop in the meantime to assist regulators in the decision making. So for example, we have done some documents on physical properties of decision trees and physical properties, so regulators can decide from the information and the tests that are available what is the most appropriate one. And this is some of the areas that we are addressing. We have obviously work on exposure, so we address both consumer, environmental, and exposure at the workplace. So developing some specific guidance, assessing guidance that has been done for the exposure of chemicals and see which one is appropriate for nanomaterials. More recently, we have been, as I mentioned, working on advanced materials because one of the concerns that we had is with nanomaterials, we were constrained to the 0 to 100 nanometers. And sometimes these boundaries are a little bit rigid when we want to assess materials. So we're starting to look at some a little bit more challenging materials such as nanocarriers, vaccines, graphene-based materials, and to see and compare how these will compare to nanomaterials using the experience that we have on nanomaterials and on chemicals, and try to integrate it in the development of these tools. So next slide, please. So as you can imagine, developing test guidelines is quite. We first need to have sufficient scientific information that can allow us to develop these test guidelines. And the development of the test guidelines is quite long because we need to make sure that we have validated methods, that the data that we're going to be retrieving from this test guideline is reproducible, that is comparable, so we can actually make conclusions that can help on regulatory compliance. So one of the concerns that we had is, okay, we're developing all these tools, but we're not going fast enough. And when you think not only on nanomaterials, but on these other more advanced nanomaterials that I mentioned, I think the idea was to start thinking if there are different ways or more different approaches to start looking into these materials and to try to speed up a little bit how we're going to be looking at. So for this, with this in mind, we have developed what we call the safer and sustainable innovation approach, which is mainly a mindset. It's really a change of mindset that is looking at further assisting in the implementation of safe and sustainable by designs approach, and at the same time enhance regulatory preparedness. And all these should be facilitated by trusted environments. So the idea is really to empower regulators to be more proactive, to anticipate what is coming up, and also innovators to start thinking in more detail about what could be the exposure route of their materials, what could be the sustainable concern of the materials that they are creating, and to start anticipating these issues in the innovation phase. If you can go to the next slide. And this is mainly what we are trying to switch, which is going to the product development, then address the safety and sustainability from the very early stage of the innovation. And hopefully by anticipating these issues, by being a little bit more proactive, by anticipating the exposure routes, in the long term, this could be something that could save on resources, both for innovators, but also to regulators alike. And in this sense, I think this is what could be relevant for the discussion of this webinar, which is really to start anticipating for the end of life of nanomaterials and nano-enabled products. Next slide. And perhaps just to summarize that what we're trying to do really is to go from science to standards and to try to develop this standardized method and generate trustable safety data for nanomaterials and advanced materials. So what we're trying to do is to have two types of parallel approach. So on one hand is to identify actions needed and make recommendations. So for example, as I mentioned, the need for standardized methods. So whether you have a need for a task guidelines, develop guidance reports, have scoping reviews to assess the maturity of the science. And on the other hand is how can we start thinking or using all these different approaches and start to integrate them in at the earlier stage of the innovation process. We have, if you go to the next slide, published what we call an early for ADMA, which is an early awareness and action system for advanced materials. And this is really a tool in anticipatory risk governance approach for decision making. And one thing that is interesting on this document is that it already asks you some very specific questions related to the physical properties of your material, to the ecotox, the toxicity, but also related to some sustainability related questions. So you can have a very early overview about where the areas of concerns could be in the product development. So for the time being, this is mainly addressing or helping regulators in their decision, but we are now moving into exploring more the screening phase and the by design phase, if you wish, so we can further empower innovators as they develop these documents. And you will have there all the links that will be shared after the webinar, and you can access the report and also the tools and the webinars that have been done in this regard. If you can go to the next slide. So just to conclude, I have shared with you a couple of slides where you have links to the materials that we have been publishing. The slide that you have on the screen right now is mainly for all these technical documents that will help you to assess, for example, the agglomeration, the behavior, the fate, the physical properties of nanomaterials. So you have the test guidelines, you have guidance documents, but you also have the validation protocols that have been performed. And together you can also, if you want to have for more details, you will have also some webinars that are available online, both in English and in Spanish. And I think Oliver has been sharing those with you as we made them available. But just to conclude, perhaps if you want, you can go to the next slide so people can see the links. Just to conclude, it really is to develop tools for regulatory compliance, but these tools can be applied on regulatory and non-regulatory risk management approaches. And we hope that the tools also help you to better understand the fate of these materials, and also that make you a little bit of reassurance that from where we started on nanomaterials 18 years ago, not knowing what we were not knowing, Now, I think there are a lot of questions that have been answered. We know what we don't know, and there is a very clear roadmap on the areas that need to be addressed to understand these materials and to understand their fate, to understand their behavior. We have made a lot of progress, I think, in this regard, but there are still many areas that have been identified for regulatory purpose that needs to be implemented. And so anyone that is interested in working in this area are welcome to contact the OECD, and we will be happy to enlarge the network of experts that can help us to develop these tools. And I think with that, I think the next slide is just to close and to thank you all for the time and for the opportunity to present the work that we're doing at OECD. Hopefully, we can continue collaborating with our sister organizations in the future. Thank you.
Thank you so much, Mar, for this presentation and overview into what OECD does. We all agree that OECD develops really great guidelines and guidance documents. And as Mar already mentioned, please do go to OECD website and check out those webinars and guidance documents. You'll have Mar's email address here if you have specific questions in regards to their activities and what's going to come in the future. Do reach out to her. Thank you so much for that. With that, now I would like to invite Dr. Fabienne Schwab. She's a grant specialist at HSLU Grants Office. For today, she'll represent the Adolf Merkel Institute at University of Freiburg and to present her latest article, research article that was published in 2023 in Nature Nanotechnology. The title of the article is The Need for Awareness and Action in Managing Nanowaste. Oliver gave a very brief introduction to that, but we're very happy to have Dr. Schwab today, the author of the article, to present it, which is very, very relevant to the webinar and dialogue today. With that, I would like to give the floor to Dr. Schwab. Thank you.
Thank you, Manoush. I don't see my slides yet. Could it be that they are not there yet?
Do you see them now?
Nope. I still see the last page of the previous slides. Here we go. Thank you.
Great.
So thank you, Manoush, again for the introduction. Today I'm going to talk about some practical insights that I had in the laboratory on nanowaste. Next, please. I first thought I'm giving you some details about my background, but then I thought I don't want to bore you with the CV. So instead, I'm presenting you here proudly my nanowaste track record. I started off with a PhD at ETH in Switzerland, and I did algae plant nanoparticle interactions first. And during my PhD, sort of the type was 2008 to 2012, I produced about 100 liters of aqueous carbon nanotube suspensions, 1 liter of carbon nanotube suspensions in various organic solvents. Then I moved, I got some fellowships and moved to Duke University in the United States, and then to the University Aix-Marseille in France. And there I started to work with plant nanoparticle interactions. And during this time, I generated quite a lot of nano waste because I was also working with large outdoor mesocosm facilities. So I produced during this time about 100 liters of aqueous gold nanoparticle suspensions, 1 liter of aqueous gold nanostar suspensions, 200,000 liters of less than 1 ppm diluted nanoparticle suspensions containing titanium dioxide nanoparticles, gold nanoparticles, and carbon nanotube suspensions, various quantities of fullerene suspensions, and very small quantities of other kind of nanoparticle suspensions, and also quite some solid waste, at least 20 kilogram of gold nanoparticle contaminated soil, plus all the dirty consumables, lab consumables, which also contain nanoparticles. Then I moved to the University of Fribourg in 2017, where I started to develop nanofertilizers. And there, I'm proud to say that I was able to minimize my experimental setups mostly. So although I did quite a lot of research there, I only produced about 300 liters of aqueous silica nanoparticle suspensions plus some solid waste of consumables. Next slide, please. During my work with the nanoparticles, I realized quite a lot of problems with this nano waste. First of all, I worked in different countries, and in every country that I worked, the regulations were different of how these nanoparticles, how this nano waste is treated. And sometimes there were even difference between the different institutes within the same country. Even in Switzerland, there are differences. So it's just, there is just no international consensus, and so this makes it really hard to have a consistent nano waste handling. Then also, what bothered me during this time is that nanomaterials, obviously, as the previous speakers explained very nicely, they behave differently compared to the bulk material, but they are mostly not regulated differently compared to the bulk material. And one example is carbon nanotubes. They're not present, explicitly mentioned in the Basel Convention. And so in principle, I'm a little bit provocative now, but they could in principle be treated like charcoal because it's also carbon. But of course they shouldn't. So what do we want to do with liquid nanowaste or all these lab consumables which are contaminated with nanowaste? That was really a question for me. Next slide, please. So in that article that we published, we propose a new solution, and we have used and implemented this solution at the University of Fribourg already, in the laboratories of Barbara Rotten and Alke Wink. And this approach broadly focuses on the different types of waste and categorizes them into waste, nano waste with decreasing risks. So the highest risk of nano waste is posed by aerosols usually. Then a little bit lower risk is posed by loose powders. Then when it's in suspension it's already less dangerous. And at the end, we have the composite nanoparticles embedded in the composite are usually quite safe. And what we are trying to explain to the lab users is that they should try to turn they should try to convert their waste into a category which is less risky. Next slide, please. And in practice, this looks like this. So we have, you don't need to read the detailed slide here and all the different lines of this table, but this table broadly shows you all the different waste categories which are present in a typical lab. And you see the blue line, the blue rows, these are the nano waste categories. And overall, we managed to consolidate all the different nano waste categories into just 4 different categories of liquid and solid waste. And I'm quite proud of this because in the beginning, there were just like hundreds of different bottles with different waste. And that makes users very confused where to dispose their waste. And it's also creating a big decision fatigue during the daily lab work to always have to choose between many different bottles. So the less categories we have, the higher is the user compliance. Next slide, please. So here you see how this looks in practice with the nano waste container. We have the white bucket which contains the solid nano waste. We have the blue bucket containing mixed solid nano waste, which is also biohazardous. We have the white container which contains aqueous liquid waste, and the green container containing organic nano waste. Next slide, please. All these waste containers we have labeled with a new nano waste label, which we have made in accordance with UN laws and the globalized harmonized system. So here you see the label for solid nano waste, and we try to make them as clear as possible. Also, we try to combine them always to have the same label for storage and transport on one container, because with this we minimize the exposure of the environment and of workers, because there is no transferal needed of waste into another container when you transport the waste. And we also mention, we try to make it as user-friendly as possible by adding explicitly all the nanoparticles that can be added to this waste, and by stating the hazard statements and the precautionary statements which are specific to the nanomaterial which is in the waste. Next slide, please. Then we also developed an waste hazard. We also developed a risk matrix, a decision matrix for people in the lab which have to decide how they are going to dispose their waste and which container to choose. So, for example, in the blue row, you see if there is a solid waste that contains nanoparticle, that contains hazardous chemicals, and that contains biohazardous materials. This has to be double bagged and will go into the solid mixed biohazardous waste. Next slide, please. We also developed initial treatment options to deactivate the waste on site again, because we also believe in the principle of generating as little as possible of the nano waste in the first place, and then also trying to deactivate as much as possible the waste again. This is to minimize the amount of nano waste that has to be transported elsewhere for deactivation or disposal. Next slide, please. So with this, I'm already at the end of my presentation. I would like you to remember that nano waste is real, it can be handled, and the typical sign, and it's not small amounts which are generated of this waste, is quite big. Even one single person like me, and I'm just I was just a normal ecotoxicologist working with nanoparticles. Because of this research, quite large amounts of nano waste were generated. So it is a real problem, but also it can be handled. We have regulations in place which allow us to be, which can be adapted for nano waste, but we need special guidelines. We need guidelines which show us how we can collect, store, and label, and dispose and deactivate the nanoparticles, and this will work differently compared to bulk waste of the same material. And being here with other people working on the Basel Convention, I would like to mention that, in my opinion, that the Basel Convention would strongly benefit from an amendment such as a technical guideline or the inclusion of nano into the annexes to avoid any safety problems in future with the nanoparticles, which will also increase the acceptance of new products containing nanomaterials if we manage nano waste safely from the first place. And the last thing I would like to say is that we should be careful that we are not over-regulating nanomaterials, because that will prevent innovation with nanotechnology, and this should also be kept in mind. Thank you for your attention.
Thank you so much, Fabienne, for this presentation. I very much appreciate that you started your presentation with giving an estimate of how much, as a scientist, how much of waste one could generate. It was for me very interesting because I did not do that estimation when I was doing my PhD, and I remember that I generated also a lot of nano silver, nano titanium, zinc, and all the other ones. But it's in fact, when you actually put it into numbers, you realize that it could become a potentially an issue if it's not soundly managed. And thank you for that introduction into collection, storage, labeling, disposal, and deactivation of nanomaterials. I'm pretty sure that our participants today really appreciated what you presented. Thank you.
Thank you.
With that, I would like to invite Dr. Pavati Ankavatana. She's a Deputy Executive Director at Thailand's National Nanotechnology Center, Nanotech, Government of Thailand. We're very pleased to hear today from Dr. Pavati and learn a bit about national strategies in Thailand and their work on nano labeling. With that, I would like to welcome Pavati, and you have the floor. Thank you.
Thank you very much, Manus. Everyone see my slide on screen, right?
Yes, we see it.
Okay, thank you. So my name is Pawadi from Nanotech Thailand, and today I would like to present to you on to introduction to Nanotech NASDA, where I am working with. And then second part will be Thailand experiences on nano safety policy and activity. And the last part would be the value added to business with nano label. Sorry about I haven't have much experience on to the waste containing nanomaterials at Nanotech. We have just very little thing that we have done. So today I won't be able to get into that into detail. So talking about our organization Nanotech, we are located in Pathum Thani in the Thailand Science Park. We are one of the research unit. Our neighbors are biotech, which working on biotechnology, and MTech as the material technology center. NECTech is the electronic and computer center, and Nanotech, of course, we are working on nanoscience and nanotechnology. And now we have another technology center as the new one called NTech, which is Energy Technology Center. So for Nanotech Visions, we aim to be research agency of excellence in nanotechnology, innovation for national economies and society upgrowth with sustainability and international recognition. Apart from what we have done for our laboratory, we also have 11 of the research network of nanotechnology working with us at the university, at the Thai university. So we have 11 of them all over Thailand. In terms of international strategic collaboration, we have worked with 24 institutes that we call strategic partner, such as Australia, China, France, Germany, Japan, Korea, and UK. The criteria that we call them as strategic country because our nanotech researcher have been working with them as the research project, and also they have collaboration working about 1 to 3 years, and they have also publication like co-author together and co-patent together as well. In terms of industry customer, we have more than 200 existing customer, and also Nano Safety Network Association that we work with them. So this is the summary of Nanotech today. We have about 249 employees, 5 research group, and 17 research team, which I will talk into detail on the research group and research team in my next slide. So this slide just want to focus on we have our past performance. We have about 100 industrial prototype, which 50% of them are launched, and then about 1,074 patents, and half of them are granted. Out of 1,070 some of the patent, more than 10% of the IP that become utilization by the Thai industry. So on the right hand side, it's just the outcome and impact of the even Nanotech funding by Thai government. We also be required to make some income for 25% of the R&D spend that we spend annually. So this is the total income that we make for accumulative. And the last part is the socio and economic impact estimated output that we have about 40,000 million baht. So as I mentioned about the 5 research group, we have so-called NCAP as the top right here, nano encapsulation research group, which there are 3 teams working in this group, such as nano life and cosmeceutical research team, nanomedicine, nanoparticle and cosmetic production. And the next one is the responsive material and nano sensor. They're working on nano diagnostic device, nanorobotics, and nano needles as well. So this group, they have the platform to make the nano rapid antigen test when we have the COVID crisis during past few years. Then this group can provide the COVID test for the whole Thailand size park, use their COVID test. The next one is the nano catalyst and molecular simulation research group, and the team that working under them are catalyst team, nano simulation team, and nano informatics team. The next research group is called nano hybrid and coating. They are working on environmental nano coating, nano functional fiber, and also nano hybrid for industrial solution. So the last one is called advanced nano characterization and safety research group. This group, there are 3 teams, which is monitoring and process engineering lab, nano safety and bioactivity research team, and also nano characterization research team. So in this slide, I would like to share some experience on Thailand experience on nano safety policy and activity. From the top on cascades down, I would like to mention that we are among the very first country that have the nano safety ethic and strategic plan, which is at the bottom of this slide here. But before we have that, we of course we have to have the Office of Policy, the Office of National Science and Technology Policy, we call as NEXPO. They are focused on to national science, technology, and innovation policy in Thailand, and started since 2012. And then after this national plan, we also have the 8 and 9 of the national research plan, which is covered until today. So because NASDA is under the Ministry of Science, so we have to have our master plan must fall into these 2 plans. So if you can see cascades down, we then have, so nanotech have under NASDA, so nanotech has nanotech master plan, and each of our master plan lasts 5 years. And now we are on to nanotech master plan 2017 to 2021, which is extended to this year 2024. I think maybe next year onward, then we will have the next master plan, and also the nano safety and ethics strategic plan, which I will go into detail a little bit onto this slide. In Thailand, the first nano safety and ethics strategic plan was started for the year 2012, and now on to the second plan, which cover the period of 2017 to 2021, which is now extended to this year 2024. Since nanosafety is still the matter of concern for policymakers, therefore we think it may be a good idea to incorporate this issue together with the guideline for ethical impact assessment for nanomaterials and products containing nanomaterials for implementation at the same level. So in this strategic plan, we have the vision to be safe nano for Thailand's sustainable development, and the objective of this plan is to enhance health and environmental safety, as well as to promote social security through ethical, sustainable, and proper engagement in research and development, production, and distribution of nanotechnology and nano product uses. So in order to complete or to execute this plan, we must have 3 strategies, which are listed here as the to establishing and implementing of the knowledge management in nano safety and ethics and nano products. And the second strategy is to develop and to reinforcing measure and monitoring mechanism and enforcement, and to strengthening and promoting public engagement activity. Of course, of this strategy, we have the label, the nano label, so-called nano Q, which I will talk in the next slide. Apart from the government partner, we also have the nano safety network for industry as well. In nanotech to be the core team, and we work with the 8 organizations in Thailand, collaborate to develop nano safety network for industry. If you see from this triangle, we must join hand with the regulators and technical support and users. So these 3 parties join hand, and then when the regulator will say that what regulate that they would like to have in the industry. When the industry have some new product containing nanomaterial, they then come to technical support, Nanotech and National Institute of Meteorology and the COSTAT, which is the Council of Scientific and Technological Association of Thailand. These parties work together and then join hand to make the standard and nano safety awareness to be used for our user as the Office of Consumer Protection Board, Nanotechnology Association of Thailand, and the last one that become our partner is the FTA, which is the Federal of Thai Industry. So this FTA, they have the industry, the Thai industry become their member. The number are 15,000 companies that become their FTA member. So we think that this is a good way to have the public awareness for the standard and nano safety in Thailand. So my last part of this talk, I would like to propose a little bit, to share some experience on to value added to our business with nano label. So in Thailand, we have nano Q, which is the voluntary label issued by Nanotechnology Association of Thailand. This party are not only the government, but the member of this association are composed of government entrepreneur and also industry and also regulator as well. So we issue the so-called nano Q in order to guarantee the product that containing nanomaterials, nanoparticle, which is corresponding to its claim property. And so far, we have 4 types of nano Q label. For the blue color are for nano products, and the red one for raw materials. And if customer would like to have nano Q for their intermediate nano product, they can have as well for the green label. And for nano encapsulation, such as powder or encapsulation to use for the cosmetic and cosmeceutical, then they can ask for the nano Q for the orange color. So this is my last slide. Just want to show some example of our nano Q product. For example, the company called TOA, that famous big company for making paint, they come to Nanotechnology Association of Thailand and asking to have nano Q on their paint, such as 4 Seasons Advanced for interior paint. And this company, Consent International, they make the smart coating by nano titania, their product called Amor 8. So they have the product also winner for the innovative product, and then they also have nano Q. So the product that can have nano Q, they must have the property that they claim for. For example, Nanotech, as a technical team, we work closely with the Nanotechnology Association in order to guarantee that the product have technical property and also respond to what the company claim for. And the last example is the ambulance car that they have the nano coating for the company called Supira, that they also have nano Q. So now, so far, we haven't had the company that asking nano Q for the the orange one, the encapsulation, we haven't had that, but we have, apart from that, we have all the nanotube, blue and red and green color. So thank you very much. I would like to end my talk here.
Many thanks, Pavadi. That was amazing to hear from Thailand and what you guys doing in terms of technology and in terms of advancement. Also, I was very interested in the Nano Label initiative. And at the end, I would probably get back to you with questions on that because I think that's a good initiative and it could be very helpful also with the sound management of waste at the end of the life cycle of those products that contain nanomaterials or the bulk of the nano materials that are produced. Thank you. Thank you so much. And thank you to all of our speakers today, and my sincere gratitude for taking time to present. I'm going to look at the chat for questions. There is one question for Fabienne, and I see you responded to that briefly, but if you like to maybe explain more, I'm going to read the question for everyone. Is it possible to detect nanomaterials in waste in any analysis, or is it necessary to specifically search for them? For example, in the leaching from landfill, analytical methods for detecting metals, for example, XRF for metals serves as a screening method, nano cadmium, nano iron, etc. as given examples. If you like to allude to your response, Fabienne?
Yes, the short answer, yes, it is possible to see the nanoparticles in different complex matrices. They can be found specifically down to one nanomaterial, down to one single nanoparticle using transmission electron microscopy or scanning electron microscopy sometimes, if it is coupled together with the elemental technique, which can quantify the elements, or with elemental mapping. And it is that there's also possibility to analyze leachates using single particle ICP-MS. Probably you heard about that as well. And there are a couple of different techniques, and there are even some initial studies which have analyzed real leachates of waste or landfills to look into the nanoparticles which can be found in these landfills. And there are a couple of my colleagues which have been working on this. So this is possible. It's not scalable so far. That's a little bit the disadvantage, but I think the ICP-MS is also scalable.
Great, thank you for that. I see no more question, but I have a question for Pavadi, and then I have a question for all the speakers. So stay with us. Dr. Pavadi, how has been the take up? I saw, so you gave some examples of nano label, and I wondered that the take up by industry and manufacturers has been pretty good, but what is the incentive for them to go with this nano labeling in Thailand? Is there a particular incentive, or this is really coming on a voluntary basis and they have embraced the initiative?
Right. At the moment, all those labels are voluntary label only, no enforcement. But anyway, now we try to make this as the very, very good standard for national standard. So people talk about the nano label and they want one, like they want, if their product containing nano material, then they want to have the label. So it become like a marketing PR at on its own. And the government, when we saw that happening, so the government tried to make it as for example, we have something called the list of innovation products. So this, if the product of the Thai industry, if they can be on the list of the innovative product from the government, they have the incentive of the government sector must order from them more, at least 10%. For example, paint, if the government would like to renovate their building, then they must buy from TOA 10% because TOA has on the list of the innovative list product, something like that. So then the list of innovative product, they have one requirement of they must have good standard, and NanoQ is one of their standard that they accept for the product that have standard. So I think we are looking at the very good future for the voluntary basis of the NanoQ, nano label.
Amazing. Thank you for that. And I have a question for all
Sorry,
speakers.
Manoush,
Yes, please.
can I ask a question?
Yes, please.
Yes, thank you. It's for Ma and from the OECD, and I thank you for the presentation. And it's great to see that there's all this work going on to harmonize methodologies for detecting and analyzing nanomaterials, and because well, obviously one of the difficulties in drawing conclusions on the impacts of these materials and their waste is the lack of comparability across studies. So it's great to see that, as you mentioned, there's been a lot of advancement in this field and now much more knowledge available to understand what nanomaterials are. But the other aspect that I found equally exciting was this tool that you mentioned about design of nano products, was it? Because waste, I think the report that we produced was all about exposing the difficulties in managing waste, in managing materials at end of pipe, right? Once they are the waste are generated, and as we all know, the best waste prevention principle is really not to generate the waste in the first case. So having an approach to try to address this upstream sounds really great. So I'm wondering whether now this, what is the uptake of this tool? Is it used with industry, or who are the end users, and to what extent has it been applied?
Thank you, Melissa, for the question. So there, how can I start with this? So what we are trying to do with this safer and sustainable innovation approach is to propose a different way to address risk management, and to be a little bit more preventive, and to try to be a little bit more anticipatory, both at the innovation for the innovators and from the regulatory point of view. So what we have done so far is really to provide all this framework, to provide some working descriptions about what we mean about safe and sustainable by design, what we mean about sustainability, because as you know, those are words that are commonly used. But again, what we try to have is some tools for comparability. The area where we are developing this safe and sustainable innovation approach is really focused on nanomaterials and nano-enabled products. So in Europe, for example, with all the Green Deal, they have funded a lot of research to develop tools for the implementation of safe and sustainable by design. And many of the examples are on nanomaterials, and nanomaterials because it's something that you can, let's say that it's like it's an area where you can create and there is a lot of innovation. That is something that, of course, we don't want to hinder. And what we are currently doing, for example, is we have evaluate different tools and frameworks that have been developed by these European research projects. And what we have done is to take the elements from our working description on safe and sustainable by design, on sustainability, and to identify to which extent you can use these different tools, depending on the purpose or the areas that you want to cover, whether it is, but it's really about integrative tools. So whether you combine some element of toxicity with some element, some economic factors, some exposure factors, etc. So I would say that it's at an early stage, and I would say that it's also something that will need to take time because we're still trying to combine very traditional risk assessment approach with this different mindset and how to put them at the very early, to start thinking about all these tools, but at a very early stage when you design your materials. The design materials is a little bit tricky because as you have mentioned in your talk, we always lack of data, we always lack of information, and what we're really trying to move is to this area of uncertainty. So how are we going to be addressing all these considerations when we don't have data? Okay, so this is one of the challenges. And for this reason, what we have done so far is mainly useful for regulators, like to identify what's coming up and what are the issues that they might be facing. But now we're moving a bit more to develop guidance and tools for innovators and for industry to start anticipating when they produce materials. So I would say that it's an early phase, it's going to take time, but combining these regulatory and non-regulatory approaches, I think we could in the future have sustainable materials from a very, very early phase. But again, it's about thinking, it's not only thinking about risk, but perhaps also an invitation to start thinking about developing materials that are safe and sustainable from the beginning. And that you can, it's really about anticipatory risk management. But yes, I mean, it's work under development and giving you really like the babies that are starting to grow at our end. I hope this gives you a little bit more idea about where we are.
And is that then, I mean, are you linking into all the work happening on green chemistry, as they call it, which I think have the same objectives, right?
Yeah, I think we're taking a little bit step forward, and it's really about it's really about the lessons learned from the green chemistry for circular economy, from risk management, for all these new risk assessments approaches that are coming up, for example, from NAMs, AOPs, and how we can integrate these new tools or this into this new approach for anticipation. But again, the extent in which you can implement this will also depend on the approach that you have at the national level. I mean, you heard from Pavadian in Thailand that they have a quite proactive approach about labeling, for example, and in other regions you will have something a little bit more the precautionary approach that will perhaps bring different solutions in how you implement this. But I think incentivizing could be one way. If you can incentivize these types of approach, that will be like something, or if you enforce them from if it's regulatory enforceable, which is not the case at the present time.
Thank you.
Melissa, please stay on. There's one question for you. The waste containing nanomaterials is on the agenda of Basel Convention OEWG that would be taking place in June 2024. Could you please say a few words to it from George, Unitar?
Thank you, George. And as I alluded to in my presentation, the Conference of the Parties, considering the report that was prepared by the Secretariat, picked up some of these elements which have really focused on promoting and encouraging further work among parties and within parties on filling the data gaps and looking at strategies for the environmentally sound management of waste containing nanomaterials. So there is a call for information that is open to parties and observers to provide such information to the Secretariat, and this is then brought to the attention of the conference of the parties, and before that to the open-ended working group, which is the technical subsidiary body to the Basel Convention. And as mentioned, the next OEWG will take place at the end of June, well, in 2 months now.
Great, thank you, Melissa. I would, because we have a little bit of time, I would like to ask you to respond to one question in the poll. We would like to explore the topics for future webinars. You can access this poll through a direct link that my colleague is going to drop in the chat box. You can click on the link, and we would be happy to hear from you. You can add your answers in a free text, suggest topics that you'd like to see we focus on. As you saw today, it was very general. We tried to give you a broad overview. And so thank you for responding to the poll. Just a couple of seconds for the link to, yeah, the link is there. Please click on it. Respond. Thank you. So I shared my screen. I hope that you can see we have topics like nanotechnology in healthcare, control of nanoplastics, nanowaste and regulation, webinars together with the private sector, in particular with chemical industry, nanowaste deactivation techniques, nanosafety for industrial workers, more on nanowaste, nanoplastics.
Just would like to make a comment to Paradis. I was very impressed about this labeling system. This is really nice, and I would like to. I think we should have something similar here in Europe or in Switzerland, because that would automatically make it more look like a feature, not like a threat to have nanotechnology in a product. And it can be linked with the nanosafety.
Thank you, Fabienne,
That's my
for
2
that.
cents.
Thank you so much. If you don't mind, you could also write to me because I have a little bit of background noise starting here, so I might have missed part of your comments. But we with that, I think I would let the poll run for a little bit longer, but then I would like to thank again all of our speakers for today for taking the time out of their busy schedule to present. And please do get in touch with us. As Melissa already mentioned, parties and observers are welcome to submit their activities aimed at addressing issues related to waste containing nanomaterials in accordance with the Basel Convention Decision 1613. And all those submissions will be available up online on our webpage. And there would be an information document submitted to OEWG that would compile all of that submissions and information. Thank you so much again for joining us today, and hope to see you soon, very soon. Have a great day. Bye.
Goodbye.
Bye.
Thank you.
Sorry,
Thank you, bye.
Menus. Menus. I
Yes,
I
yes.
changed my slide have changed a few of them since I sent to you, so I would like to send it again to update. Okay.
Sounds good. Great. Thank you.
Right.